Hello everyone. This video I am making on the request of few of my students. They were struggling with this JEE Advance problem. So this problem is basically from fluid mechanics, but the concepts used over here are both involving fluid mechanics as well as thermodynamics. So this was a bit of a difficulty for them. The question is very simple. We have a container, a cylindrical container, whose upper half is unsealed and we have a small hole at the bottom. The height of the container is 500 mm. The height of the fluid is capital H. This is water over here. So fluid and water, I'll use this interchangeably. The height of the water H is not given to us. This is unknown to us. Then what is done? The top part of this cylindrical container is sealed and this hole over here is open. The orifice is open. What would happen? Some of the water would come out. After some time, what's going to happen? That this the water level would stabilize. That means no more water would be coming out from here. So we have to find out by what height the water level has decreased. That is the question. Now let's solve very quickly. Over here, what do we have? We have to, as I mentioned, we also have to talk about thermodynamics a little bit over here. So if we talk about the gas inside of this container, as soon as you seal this container, what's going to happen? The amount of gas inside it is not going to change. So let's see what we can do. Initially, let's suppose the pressure is P0, which is going to be atmospheric pressure, and volume is V0. The area of cross section of this vessel is going to be A. So initially we can write P0 V0 is equals to nRT, where T is the temperature of the surrounding. Pay attention that this temperature is not changing. That's going to be useful. So this temperature is not going to change. Let's suppose this is equation 1. At the final stage, what's happening? Since the amount of gas is same, but the volume occupied by the gas is changing, so the pressure is also going to change. Let's suppose the pressure over here is P and volume over here is going to be V. So again, we can use the ideal gas equation. We can say PV is equals to nRT. As the temperature is not going to change, the right side of the equation is not going to change. So from these two equations, we can say P0 V0 is going to be equal to PV. Let's put the values over here and find the value of P. So P0 is atmospheric pressure PA, volume is area of cross section into height of the gas. Height of the gas is how much? 500 minus H. Pay attention that we have taken H in mm. So this is going to be 500 minus H. Over here, we don't know the value of P, and volume of the gas over here would be how much? The height of the air column is going to be 500 initial height minus, suppose this is some value H, 500 minus 200, final the level of the water over here, that's going to give you 300 mm. So I hope everything at this point or till this point is clear to everyone. So volume would be area into level of the water, or level of the fluid, level of the gas inside of the vessel. That's going to be 300 into 10 to the power minus 3. Over here also we can multiply with 10 to the power minus 3, converting everything into meters. So 10 to the power minus 3, 10 to the power minus 3 can be cancelled. Area of cross section, area of cross sections can be cancelled. So from here we get P as 500 minus H upon 300 into atmospheric pressure, which can be simply written as 10 to the power 5. We can take atmospheric pressure PA as 1.01 into 10 to the power 5 pascals. We are just approximating it into 10 to the power 5 pascals. So yeah, don't confuse with this pascal over here. You can just simply write this as Newton per meter square. Newton per meter square. So this would be atmospheric pressure. Once we know the value of the pressure, what we can do? We can now apply Pascal's law. Since the fluid is not moving, we can apply Pascal's law for static fluid. We can say that the pressure at B would be equals to pressure at A. We are taking one point A on the surface, the interface between the air inside the vessel and the water, and B is the point at the bottommost point of the vessel. See, since B is near the opening, so at B the pressure would be equal to atmospheric pressure, and at pressure A we will have, pressure B can be written as pressure at A plus pressure exerted by the height of the fluid, rho GH. This is rho GH itself would be gauge pressure exerted by the column of the fluid. PV is atmospheric pressure. PA we have already figured out. From here we are using PA. Over here, the pressure exerted would be same as pressure exerted by the gas. So 500 minus H by 300 into 10 to the power 5 plus density would be 10 to the power 3, G would be 10, and H is how much? H is 200. 200 into 10 to the power minus 3. So this would go away. We'll have PA, which is 10 to the power 5, simply over here, is equals to 500 minus H by 300 into 10 to the power 5 plus 2000. What we can do is we can shift this value over here. So we'll have 10 to the power 5 minus 500 minus H by 300 into 10 to the power 5 is equals to 2000. We can take 10 to the power 5 common, divide. What are you going to get? 1 minus 500 minus H by 300. I hope now just calculations are remaining. I hope you can also do very quickly with me as well. So 10 to the power 5 would be at the bottom. You'll have 300 minus 500 plus H by 300. And this would be simply, see, 3 zeros would go away, so this would be 2 by 100. This 100 would take away 2 zeros from here. So we'll have minus 200 plus H is equals to 6. This 3 would go over here. So the final answer we are going to get for H. Remember, this is not the final answer. The final answer is not 206. H is equals to 206. We are taking this minus 200 over here. The question was asking to find the level by which the water level, the amount of water which is coming out, or the height by which the level of the water has reduced. So delta H would be how much? Initial height minus final height. So delta H would be equals to 206 minus 200 mm. So that's going to be 6 mm. Delta H. So this is the height of the fluid. This is the height by which the level of the fluid is reduced in the vessel finally. So again, I hope this video is useful for you. Thank you for watching. I'll give you 1 more minute to just quickly go through this. Yeah. Again, thank you for watching. Bye bye.